Now, there comes a time in our study when we need to verify if our mesh is having an impact on our stress results. As we've mentioned in class, a typical rule of thumb is to have at least 2 elements across a material thickness, at least 8 elements around a circle, as long as they're curvature based. But these again are just rules of thumb. It's always important to make sure that your stress results are converging and the size of your mesh no longer plays or has an impact on your overall results. So what I've done here before we've tuned into this video is I have taken one study where I started that out to have a coarse mesh, and I'll just run my results very quickly with that. And then on static 2, I just copied that study over and I changed my mesh to be, by pressing reset, to move my slider to the middle. And then on static 3, I just moved my slider for my mesh all the way to the right side. And again, of course, you can go smaller or larger than whatever the slider will give you by inputting your own values. But now that I've done that, I have my stress results for each plot. And as I click on different ones, you might be able to realize that my stress number does change a little bit. One of the easiest ways to see quickly all of your results is to just use the compare results tool. In this case, I'm going to make sure that I have all studies in this configuration selected. I want to have stress 1, and stress 1 in static 1, 2, and 3. Those were all where I changed my global mesh in order to see what happened to my stress. So I just click compare, and I see my peak stresses, and graphics don't look that great. I'm trying to have as small of a video as possible, but it still does show me my peak stress on each one of these situations. So this is my first study, this is my second study, and then this is my third study. So if I go over to Excel, I'll just copy these numbers over. 5.2 times 10 to the 7th, 5.8, and then 5.82. So within Excel, what I like to do is I always have a Convergence Excel file set up and just save somewhere. And I have it set up 2 different ways. The first way is with degrees of freedom. So I'm looking at, and I'll use this one whenever I'm just making global mesh changes, and then I report out my maximum stress. The other one, though, I'll use whenever I'm using a local mesh, where I'll be putting in my element size. And as I apply a local mesh, I get a smaller mesh. But in order to make my trend behave in the same way, I need to take the inverse of that with 1 over h. And then I put in my stress results there as well. So in just looking at data I had in here previously, this data over here shows that I converge after my second study. So I could start to trust my results at this point. Whereas this study over here, based off of this information, actually never looks like it's converging, and that's probably a sign I have a singularity somewhere in my analysis that I need to address, either by ignoring it or adding some fillets. All right. Now as I look at my results, I see that I have 53 megapascals, 58 megapascals, and 58 megapascals. So I'll go ahead and input those into my Excel sheet. Oops, I already did. 52, 58, and 58. And then over here is my degrees of freedom. So I'm going to be looking at my global changes to my mesh. And to find those results, I'll just exit my compare. I'll go back to static 1, right-click on results, look at solver messages, and I could read my degrees of freedom right off of here. Go ahead and pause it while I enter in all my values. So now that I have all of my results in, I do notice that I have my first study with just 4,000 degrees of freedom. I'm kind of underreporting my stress some, but once I increase my resolution, or I shrink my mesh size some, I start to see that I'm converging right around 58 megapascals. When I set up these axes, I like to make sure that I'm always zeroing my stress plot. so that it's easier for me to see when I'm actually converging on a value. If I don't zero my stress plot and just let Excel automatically create it, it might give me a very small window here, and I might think that I have not converged when in reality I have. Now, let's take a look at a second approach for us to be able to be managing our mesh size in order to get more accurate results, and this one would allow us to better control our solution time. So from static 1, I copied that over to mesh control 1, and the only addition I did in that case was I went in and I added mesh control. And I see that my element size is 2.4 millimeters in this particular case. And then I duplicated that study, and then I changed my mesh control, and I made the elements even smaller on this one. So I can do the same thing here with my results. I can go compare results. And this time what I want to be checking though is I'm not worried about static 2 or static 3. I'm worried about my first study, static 1, with no mesh control. And then I want to compare what happens with my stress results with mesh control 1 and mesh control 2. Hit the check mark. And I can again see my results here. So I'm at 52, and then I'm at 60, and then I'm at 58. So we'll go back, input those values, and now I've got my values in, and I also need to input my element size. So in order to do that, I'll need to go back into my study, and I'll need to find out the element sizes along that fillet because that's where I'm creating my mesh control. Now in my first study, I didn't use mesh control at all, so I'll just right click on the mesh and look for details. And from there, I'm looking for my minimum element size is going to be 3.8 millimeters. I can look at mesh control 1. But this time what I'm concerned about is my mesh value here. Right click, details on the control itself, and now it says my element size is 2.38, and then I'll just repeat the same thing for mesh control 2. An alternative to using, and let me go ahead and put those values in before I stress one last point. Now I have my values into my Excel plot. And I could see that, again, I'm starting a little low here, and then I come up to this value, and it looks like I start to drop down. If I was to do some more studies, typically what we would see is we would start to be hovering around, right around this value between 58 and 60 megapascals, and then thus we could say that we converge once we do our first mesh control, and we can use that to make our model solve quicker. An alternative to using the simple plot to find your results and just looking at your maximum value here is, remember, we always have the potential, and this works very well if you have a model with several different areas on it that you need to find what your peak stress is, whether it's for convergence plots or whether it's just for your own analyses. If you just right click on your plot and choose probe, if I switch it to on selected entities, select that face and hit update, I can scroll down and find out what my maximum stress is along that face, which is 58 megapascals. Thanks, and good luck in your analyses.